Okay, so let's do an endothermic reaction since we are in an energy chapter. What I'm going to start with is some ammonium chlorate solid. Put it into a conical flask with a funnel. Just going to pour it all inside. Side note, if you're going to do this at any point, anyone watching, please do it in a fume hood. I had a mask on, so it was helpful. Right now I'm going to take some liquid water, put it on a piece of wood. You'll see why in just a little bit. Okay, put the conical flask on top of the water. Now I'm going to add barium hydroxide, also a solid. A little bit more crystalline in its texture, prettier. Notice they're both solids. I haven't added any water inside the conical flask. Now I'm just going to stir it. Have a little glass stirring rod. So if you're going to do this at any point, please do not inhale the fumes. Stay away. It is a very strong odor, and you do not want to inhale what one of the products is, and that's ammonia gas. So notice it starts to form a slurry. Kind of gets like looking like snow, more like wet snow, and then it gets slushy because a reaction is happening. So the ammonium chlorate and the barium hydroxide are reacting, undergoing a double displacement to form ammonium hydroxide, which is then emitting ammonia gas, leaving behind water, and barium chlorate. This is an endothermic reaction, which means that the surrounding area should get really cold because it's pulling in thermal energy from the surroundings. So delta H of the surroundings is negative, but delta H of the system is positive. So look, notice it looks really wet right now. So I'm just going to leave it on that wood for a minute. And I thought of something when I was doing this. I've done this experiment so many times, but I thought, oh, I could see if it's actually emitting ammonia, if the reaction is still happening, by getting a piece of litmus paper, red litmus paper, and if it turns blue, that means that it's still emitting ammonia, because ammonia is a base. So I went over to get that. When I come back, I'm going to put this inside, and notice it turns blue when I put it in the conical flask, which means it's still emitting ammonia. So the reaction's still happening. Right when I put it inside, you can tell it turns blue right away. Kind of gets lighter when I take it out just because it's not as gaseous. But inside the conical flask, it's pretty obviously blue. All right, so reaction's still happening, but I can still do this, my little magic trick. So notice because it took all of the energy from the water, it froze the water, and it stuck the piece of wood to the conical flask. So spontaneous reaction because delta S of the universe is positive, which means your delta G is going to be negative. But very obviously, this is an endothermic reaction, which means delta H is positive. And I'm just checking again to see if the reaction's still going, and it obviously is. But it's okay. Our demo is now over.